evening, everyone. My name is Elena Vilkova. I'm working in a Dutch bank, ABN AMRO, as a ML engineer for almost 2 years. And I'm currently living in Amsterdam, and I'm really happy that this year the conference is online, so many people can contribute a lot from all over the world. And today, I hope you're not too tired, and we can start our tutorial. So as Yula mentioned, today our topic is MLflow and creating experiments and logging metrics in Databricks and MLflow tracking servers. I think Yula had pretty the same example that I have, and I heard from many companies and many startups especially who have data scientist teams. Like we have a data scientist, Max, and last month Max created many ML experiments. He got a lot of nice metrics, high accuracy, and promising results. He stored ML models locally and accuracy results in his notes. But unfortunately, in a month, he can't remember which model gave the best performance. And it means that your team should repeat all the steps since beginning. You don't know which metrics gave the best performance, so which model is the best. It means some extra costs for calculations, especially if your models should calculate a lot of data. So we're here today to try to solve this problem. And that's why tracking and experimenting is quite an important topic. And today I'd like to show how it's possible to solve with MLflow. So there are a few parts we'll go through. First, we'll go through what is MLflow. I'll explain you a bit about MLflow tracking and projects before we go to tutorial, because I'm not sure that all of you already know details, and I think some terms will help you to understand code afterwards. And after that, I prepared a case, and we will work with one case, but we will go through 2 different parts. First part would be creating experiments and logging metrics in Databricks. So if you work with Databricks, after this tutorial, you can easily start. The second case would be more just best practice that we do in our company. And I'll show you just an example of how useful can be a remote MLflow tracking server, where you can share results with your team members and really have end-to-end MLflow ML model lifecycle. So let's get started. First, I'd like to introduce you MLflow. That is quite now an open source platform for managing end-to-end machine learning life cycles. There are 3 main functions: tracking, projects, and models. So tracking is about tracking experiments, to record and compare parameters, metrics, and output results. Projects is a special format for packaging ML code in a reusable and reproducible way. You can easily share code between different platforms, and it's especially very useful for production. And models, we will not touch a lot today, but that is just a general format for sending models to different platforms. So it's library agnostic, and you can just see how easily you can have some model artifacts using MLflow. Actually, I do plan to show you a bit models as well, but we will not deep dive into technical details of this part. So why MLflow is a good tool? I think the biggest challenge is having some platform agnostic and language agnostic tool, and this is what MLflow is, because you can it supports different machine learning libraries and different languages, because it communicates via REST API. That's why it's kind of language agnostic. So let's move to MLflow Tracking. MLflow Tracking component is an API and UI for logging parameters, code versions, metrics, and output files that can be your model artifacts, for example. And when you're running your machine learning code, you can just easily log all these values, and you can make by your own via just few lines of code. Actually, you can see these lines of code on the screen. That is just a MLflow log parameter or log metric or log model. After that, these values can go to tracking server, and you can easily monitor these values afterwards via visualizing in tracking server UI. And we will see these capabilities today as well. So first of all, it's very easy to start with MLflow. It's just a library that you can easily install via people install MLflow. What you should know for now, I think main point is that run is a core granular item of MLflow tracking. And later on, we will work with these runs and experiments. So I hope you will understand it better. So for ML tracking servers, there are two types of stores. There are backend store and the artifact store. We will not deep dive too much into details, but I want to show you main concept of these stores and how to use it in a best practices way, because there are multiple ways how you can organize your tracking server. I can show you a few examples how easy it is to make it. So in a MLflow documentation, you can create a server by a simple command like a MLflow server and provide multiple parameters that, depending on these parameters, your MLflow tracking server can be on your local laptop or in some cloud storage. So that's how you can organize your project. And on the next slide, I'll show you different possibilities of that. And as you can see, one kind of configuration is like this. You just specify a backend store where you will save your metrics and parameters, and you specify your artifact store where some model artifacts will be stored. So that's quite easy to do that. There are definitely some challenges when you make it for a real production, but I will show you at least how my team was able to handle with that. So coming back to the presentation, I already mentioned two types, even three types of different MLflow tracking server locations. So it might be localhost, Databricks workspace, and remote MLflow tracking server. There are much more, but I just grouped them to explain some pros and cons. So for localhost, it's not really the best practice to use it anymore, because when you run a MLflow tracking server locally, it means that only you can access your experiments and runs. It's good maybe for some testing purpose or debugging, just to understand how MLflow works, but I really don't encourage you to use it for real projects, because other team members will not have access to your local tracking server UI. For Databricks workspaces, it's much better, because Databricks workspace, if you work with that, is a nice tool for collaboration. That's why it's easy to share log metrics and results and models inside Databricks workspace. And also, you don't need some special configuration to set up. It means that data scientists who use Databricks can easily start with MLflow, because you don't need some extra platform engineering knowledge to set up or create a MLflow tracking server, because it's already integrated inside Databricks. And it's really good for data science work, when you can work, create models, and write down some parameters and metrics. And the third topic is remote MLflow tracking server. I think that's the best option for production environment, where you have a MLflow tracking server with a configured backend store and artifact store, and you know for sure a secure place where your models will be stored, and all team members will have access to it. You can run this server by yourself, so you make sure that it's all the time responding, and you can access your model anytime. And as I showed you, it's not really difficult to set up a MLflow tracking server, and I'll show you one of possibilities how it's possible to do this. But today, since localhost I don't consider as the best option, we'll go through Databricks workspace tracking server and remote MLflow tracking server. But before we go to use cases, I also want to introduce you MLflow projects. So MLflow projects is the second part of MLflow, and MLflow project is a format for packaging data science code in a reusable and reproducible way. So actually, this part is more necessary when you go to production, because this MLflow project helps you to organize your code very well structured. It means that all other data science and ML engineers will understand how your repository is organized, and by which commands, which scripts will be called, and via simple MLflow commands, you can create different runs with different parameters. And today we will do that as well. So for now, you should know a few main points of MLflow projects. So to complete a MLflow project structure, you should have a few necessary, even mandatory files. First of all, that is ML project file. That is kind of main file to which MLflow will look into when you run any MLflow command. So when you run any MLflow command, MLflow will try to find this ML project file and see exact details. So it's kind of configuration for your repository. And as you can see, you can specify some name for this. You can specify environment. Environment can be, for example, Conda or Docker. So you just specify all the dependencies you need to run your scripts, like some special libraries, maybe some Python libraries if you use Python. Third point of ML project is entry points. So entry point is just a command that will run anything you write under it. So for example, in this case, we have two entry points, train and score. And if we execute MLflow with train entry point, it means that Python script train.py will be executed. If we want to run MLflow score entry point, then the command Python score.py will be executed with a special parameter that you can also specify in MLflow command. But definitely we'll see it all in practice, and I think we're almost to start tutorial part. And the final step that how train.py and score.py files can look like. Actually, there is no difference how you call these files, but usually in ML, in ML projects, we should train something and then score something. That's why that's common used names. And in train part, we can have a code responsible for creating a model. And in this file, we can use the same commands that we saw before. For example, MLflow log metric, that will show us some score of the model on the train set. And for the score script, we can use something like MLflow log metric, and we will see some results, how good our predictions we made. So you can use any commands with MLflow. You can log more metrics and log more parameters. There's just a very small example, and the example that we will go through is wider and more realistic. So I hope you will see how good it might be. The mock case that we will go through today, I work in a bank. That's why I can't share with you any real projects that our teams are working. But I decided that it's quite boring to see some simple and non-realistic cases. That's why I decided to take one case with a lot of data from Kaggle. So let me show the case shortly. So we took this case, it's Microsoft malware prediction. Actually, we can assume that in the bank we have similar projects like spam emails, if it's spam or not. So it's somewhere similar to this. So afterwards you can go to this Kaggle page to know the data better. But main idea that we have test and train data sets that are quite big, more than 4 GB each, I think. That's why it's pretty interesting how MLflow can handle these big data sets. Since in this tutorial we're not about coding best model, so we got a repository with the Databricks notebooks of one of the participants of this tutorial, and we changed a code a bit to show you best MLflow capabilities. So if I go back to the presentation, so we get data from Kaggle, and then we need to make some extraction, transform, and loading of data, some ETL procedures. And then we go to the main part, train and score. And today we will focus on train and score. That's why I already prepared all data, just not to spend much time with you on that. And I think we can move on to first case. So first case will be MLflow runs in Databricks. So let me go to Databricks workspace where we'll work today. In our workspace, I already have all these notebooks from the Git repository. I prepared already data set, and today we'll work with this notebook where most MLflow capabilities can be shown. So first of all, we have already a silver data layer with which we will work. So we have test validation, and train folders, and each of these folders contain prepared data for training. Let's create delta tables out of that. Just some preparations. And now let's create a data frame for train data and see what is inside data. We don't need to understand too much details about data set today, and also about modeling a lot, but I just want to let you know how big the data set is that we use to have some expectations of time consuming. So we have more than 8 million rows. I think that's quite enough for showing what MLflow can do. So we have this data frame with which we will work. I don't want you to deep dive a lot into modeling part, but since we have to do this, and you will see some parts in the code related to modeling, I just want you to know that we will make some tokenization, and then hashing, and then apply logistic regression to get some predictions. And now we can go to the main part. So we need MLflow on our notebook. You can also install it into cluster. Now let's look a bit more detailed into the main part where MLflow magic happens. So we import MLflow, and as I already mentioned, it's very easy to start with MLflow, so we don't need to make any preparations. We can just directly start MLflow run with some special name, and inside this run we can make any coding that we like. Especially here, we do just modeling. So we provide some parameters, parameters for our logistic regression. After that, we split our data set into training test. I think that's pretty similar to all the cases. And after that, yeah, there's MLflow magic happens. So we just write one line like MLflow log parameter train count and test count, and we assume that when we run this a piece of code, we will see these parameters logged somewhere. After that, we make a modeling part. So as already mentioned, we apply some vectorizing, hashing, logistic regression. We don't need much details about this. We just make modeling part here. After that, we feed the model with the we apply model for the trained data set, and we have a function to get accuracy and the hook value. And after that, yeah, I think all above is pretty clear. And again, we go to MLflow part. So MLflow part now is about logging parameters and metrics. So first of all, we specify the parameters for the logistic regression, maximum number of iterations and range parameter. And also we want to log metric elastic net parameter. You can add any values as you like. So that is just values that we had in our use case. But if you have more parameters, you can log more parameters and metrics here as well. And as a result, we will get some metric for accuracy and AUK value. So we want to get these values in metric just to compare results later. And also there is a possibility that I already mentioned to log model. So for log model, we use MLflow Spark log model, and we assume that our model will be logged somewhere. So let's run this line, not really line, this piece of code. Oh, got some error. Maybe I didn't run all there. I think I was explaining a lot. So that's why my data frame just lost. And
Elena, could you please make it a little bit bigger? I think for translation it would be better for watching from mobile phone.
Is it better now?
Yeah, thanks.
Okay. Okay, we have finally our data frame. So we run just their part of code that I just explained, where the main MLflow logging part is happening. And as you can see, it's running already, but it's not finished. So yeah, there are quite some rows, but we already see that here some green dot appeared, and that is where our experiment was created. So we can see that, yeah, just less than a minute ago, there was created a new experiment run. And as I mentioned, runs are granular items of our MLflow tracking part. And we can already see a few coming values from log parameters. I think first values was train count and test count, and we can already see them. And still our code is running, so some more parameters and metrics are coming. So we need to wait a bit. I think it's almost there. Yeah, we should understand that we have more than 8 million rows, so it can take some time. And also, I don't remember how powerful cluster I have, but I think it's almost there. By the way, if you run this part of code multiple times, more experiment runs will come here. And if you want to compare different of them, it is also possible. But for doing this, you can just navigate to this view experiment UI. So we will go to a new tab where we can see our results. So that was the first one that I had some error, but that is the one that we just executed. So if you go inside it, we can already see more parameters coming. So we can see test count, train count, range parameter, max iteration parameter, and we don't see any metrics so far. I think it's not finished yet. And now it's finished, and yeah, let's see. We have 4 parameters here, and we have 3 metrics here, and we have accuracy and AUK value. So if we want to change some parameters, just to check that something happens if we change something, so we can have some different parameters for logistic regression. So if we're making new execution, we should see a new experiment run coming. Yeah, that is it, just less than a minute ago. And if we go again to their UI of all the experiments related to this notebook, we can see already 3 runs for this experiment. And if we wait a bit, I think we will get some values here as well. When it's running, I want to show you some more capabilities on the example that was finished already. So we also logged a model. That's why under artifacts, you can see your model, and you can see some dependencies here. And what is a nice feature that I mentioned in the beginning about models and register models. Then you can easily register model here, select model, create new model, or select a model. I had already one, and you can register it. And now in such a way you can make model versioning. And in such a way you can share your best models with your team members, as I already mentioned. Also, you can share notebooks. In that way, your team members can also see your experiment and runs. So if you see my model registered, there are already 3 versions that I registered in different days. So any of this version you can share with your team members, and in such a way you can easily organize your work. I think second experiment is almost done, so we can I think compare results. If we go to our experiments, it's almost there. It should be green or red if it's done or not. Okay, let's see. Yeah, it takes some time, but I really want to have it in real time. So if you see now, after registering a model, we can see that these run results. So model from this run was registered in models, and you can easily navigate to this model. In such a way, you can easily track which runs with which parameters gave you which model. So you have a very good model lineage, and it can help you to monitor and track results. So we already see that parameters for the recently executed run was a bit different. I just changed parameters to show you some results. And I think now, in a pretty nice way, I had a lot of questions like, why should we use MLflow? Why not to use some other tool? Definitely you can use like any tool for monitoring, but I think with this capabilities, it's really easy. You can just select 2 runs, you can compare them, and for example, see what changed, like accuracy changed, and you can see parameters with which accuracy was higher. So you can easily understand, you can compare a lot of runs, and in such a way you can organize model tracking. I think that's it, what I wanted to show you inside Databricks. And now I want to move to the next level, because when everything is organized like this, it's very easy to work in exploration phase, where data scientists are just creating different models. But when we go to production, platform should be more standard, and it should be better structured. And here MLflow projects come. And I told you about MLflow projects a bit. So I changed these Databricks notebooks a bit, and now I have not notebooks, but I have Python scripts. So in this repository, you can see pretty the same code. So the content of train.py and score.py files are pretty the same. We changed a bit configurations to let it work with Databricks remotely. But main idea that we have all the same code. We have the same models like vectorizer, hashing, logistic regression. We do the same fitting for train, and we log same parameters and metrics. What we did to make this ML project structure happen, we added the ML project file about which I told you before. So we created a conda YAML file with all the dependencies that are required for running our train and score scripts. So here you can see some necessary libraries that you can install, a version of Python and PySpark you need. And based on this conda YAML file, Databricks will be able to create a Conda environment. And
could you please zoom it a little bit? Zoom it in.
Oh,
a little
sorry.
bit.
I think I have too big. Oh, I don't know how to zoom. Visual Studio Code.
Sorry.
It's probably Control plus and plus plus plus.
Working. I try. Oh, yeah. I was not on plus. I didn't see on my keyboard. Sorry. Thanks. We created 2 entry points, or we have train entry point that will execute our train.py script, and we have score entry point that will make scoring with the model that we logged before. So actually now we want to do all the same steps, but not inside Databricks, but kind of remotely running MLflow commands. So for doing this, what we can do, so first of all, we should go back to Databricks. As you can see now, our experiments are inside a notebook, but to easier share experiments, we can create experiments on the same level as notebooks. We can now create a new MLflow experiment like this. We can specify a name, let's call it mlrepa, and we can create this experiment. So now we don't have any runs here yet, but we want to put some runs here from the code that I just showed you that is on my local repository, but it is also stored in GitHub. So as I mentioned, it's possible to have code, your code locally, but it's very important to have your tracking server shared. That's why I want to create some runs from my code inside Databricks. So to doing this, we have this experiment now, and I go to our command line, and I want to create a MLflow command. So for doing this, we will use Databricks Connect. If you don't know about this, you can just Google what it is, but that is just remote using Databricks. So I will run commands on my a local CMD, but all these commands will be executed in Databricks, and runs will be logged also inside Databricks. So for doing this, we should first configure Databricks Connect. So we should specify the Databricks where we want to use for execution. So I have this link to Databricks. I have my personal token from Databricks. Oh, yeah, I hope it was injected. After that, we need to set MLflow Tracking URI as Databricks. It means that our further MLflow commands will go to Databricks. And now we want to create an MLflow run. I told you that I have a repository locally, but that is not fair enough, I think. I think it's good to have everything in Git or any repository. So I use Azure repositories, and the same code that I showed you is in this repository. So I specified from which repository I want to run MLflow, and MLflow will try to find a ML project that I showed you before. Now we need to specify inside which experiment we want to log these results. And this is the experiment that we just created, and we have this experiment ID, and we copy it and we specify it here. After that, we specify that we want to run it on their Databricks backend, because there are multiple ways to run it in MLflow. After that, we specify entry point name. Let's start with train. We want to train model first. And last but not least step is cluster configuration. That is just a simple cluster configuration from Databricks that you can find anywhere. I just created this file locally, and I will just refer to this file. So that is just how good your cluster should be to execute this command. So I just specify the local place of this cluster configuration like this. So now we run it, and we should see some output that at least the MLflow command was executed well. Okay, MLflow tracking the right. Okay, let me check. Oh, I think I just forgot to add it to dashes, sorry, before experimenting. Take some time to connect from our CMD to Databricks, but we already see that fetching project started. It means that we got code from this repository that we specified, and based on this code, a MLflow run will be executed. We should wait a bit. Also, it takes some time to create a new cluster, because when we run remotely, a job cluster should be created, but at least let's try to see that a new run was registered here. Let's refresh the page. Yeah, here is it. So that is a new run that I created based on my repository and some special version like master branch, I think some last git commit. So if you go inside, we don't see so far any parameters and metrics. That is because if we open logs, we can see that Databricks needs some time to spin up a cluster, as I already mentioned. So we can see that we're waiting for cluster. In the meanwhile, we can check that the same run command was transferred to Databricks. So it takes around 8 minutes to complete this command. So we will go back to this a bit later. And in the meanwhile, I want to execute score part as well, because it will also take time. So we want to see both results. That's why I already prepared one model. So we have already under models. We have 3 versions. And if we go to one of my previous experiment, mock experiment, I made it before. So let me check where we have a model. But actually, yeah, we can wait, maybe it would be a better representation. Okay, so it's going. In the meanwhile, what we can do, okay. In the meanwhile, I'll go back to the presentation to move on, and we will go back to this part a bit later. I think most part of Databricks we already discussed. There's just a final demo that I want you to show how that it works actually remotely as well. Since we have not much time, I want to move on to the second part of the case. So this is about the same use case. So we will use the same data, the same content, and even exactly the same repository with code that we just remotely run in Databricks. But when we go to some production phase, the solution must be more robust. So different teams should have access to the same experiments. They should see all the experiments and runs in one place. That's why Databricks is maybe not the best option for production, where you can go and see all your models, experiments, and results in one window. That's why a remote MLflow tracking server comes to place. And I want to show you how we created this. Inside the tutorial, I don't plan to explain you all the details how you can deploy MLflow. It's more technical, but you can just follow MLflow documentation. It's nothing special there. But at least for our organization, we deploy MLflow tracking servers under Azure Kubernetes. So it's quite easy. I already showed you a few parameters required to create a MLflow tracking server. And as you can see, as a part of our CI/CD pipeline where we deploy a MLflow tracking server, we just specify the same parameters from MLflow documentation, like host, port, backend, where you will store your metrics, and artifact, where you will store your artifacts. So we have, after running CI/CD pipeline, we have a tracking server, and our users have many tracking servers. So for example, Max is working in team 1, and they have 10 people working on a few projects. So they can use a MLflow tracking server 1, but maybe Sophia is working in a different team with some sensitive data that Max's team can't see. So for doing this possible, we created a separate MLflow tracking server for Sophia's team, and her 5 data scientists can see all their experiments and runs. They can share results, but not with Max teams. It's quite easy in separation. That's what I mean, that you can just deploy as many MLflow servers as needed for your company. So you can easily separate teams and also allow collaboration inside. So now let's, before we go to demonstration, let's go back to our results. I hope it was done already. Let's check. I think usually it takes around 8 minutes, including spinning up of the cluster, but not sure that it's done already. Let's update results. It's running for just 5 minutes, and we can see that just it's in the process of creating Conda environment. So okay, we will go back to this in the end of demo then. Now let's continue with the demonstration of how this work organized for a remote tracking server. So what we did in our company, we created a Django application that can communicate with MLflow via different commands. So let me open CMD again. So before I run MLflow run, this kind of commands, but we just created an application that can make it much easier. So our users can just specify repository and some run details that they need to execute. That is why you will see not the same lines of code, but I think there's a good example how it can be done in production, because this part of platform is working in production, and data scientists can just easily use it without even ML engineers. So for running something now in this remote MLflow tracking server, we want to call our platform with the run post method. It looks a bit weird. We just created a library. Unfortunately, I can't share this solution with you because it's under NDA, but I'll show you that on the backend, it works pretty the same as we made with you in Databricks. It's just a backend written to execute these different commands. So we just want to create a run. We again specify backend. We again specify backend as before. It is Databricks. It means that we want to run it in Databricks. After that, we specify entry point as before. Entry point would be first train. After that, we want to specify branch name. Branch name of the same repository that I used before. It is master branch. After that, we need to have a cluster configuration. Before we had it locally, but now we just copy all the same cluster configuration inside our CLI. And this is about which cluster will be used and some environment variables required for the code. When we execute it, as you can see, sorry, I think I forgot to add for cluster config dashes again. That's my today problem. Let's see. Okay. So as let me go back before best practices, we're not there yet. So when we executed our command, that looks pretty the same, just instead of MLflow run, we have this post run. So yeah, please ignore it, it's just our backend. And after that, we also specify Databricks, we specify entry point, branch, and cluster configuration. And we see that something happened. To see results, we should go to our MLflow tracking server. So that is the MLflow tracking server that we deployed in AKS. And as you can see, there are multiple experiments here possible. As I already mentioned, different team members can create experiments. For example, I'm working with this mock case. You can see my name almost everywhere, but there is also another use case of my team member. You can see another name here, but we can easily see each other's experiments and runs. That is really good. And here a new experiment, a new run appeared, and it happened just a minute ago when we ran this post run. And if you go inside, as I mentioned, on the backend, we have the same MLflow run command with the same repository where we have our code with MLflow project, and entry point, and backend has Databricks. So it was started. And now we should also wait a bit. We can see also logs. And since it's running in Databricks, it takes some time for having clusters in place. So it's also waiting for a cluster. But I think I can just make a demonstration of my previous runs just because of the time to show you some results. So now we make a MLflow run for training in both Databricks and remote MLflow tracking server. Now just let's find what results, what are the results. So if we update our Databricks part, just to remember, we go to our mlrepa experiment, and here we see, yeah, it was succeeded. That was run around 10 minutes ago. Let's go inside, and voila, we see the same parameters as were in Databricks notebook. We see the same metrics that were in Databricks notebook, and we see a model. And we again can register a model the same as we made before. So that is how it works. And now I want to show you how scoring happens. We will not run it because, yeah, it will take more time, but we are almost out of time. So I'll show you the scoring part. So for scoring part, we run the same command, but the entry point is score, and we specify which model that we registered before will be used. And as a result of this, we don't see any parameters and metrics because we didn't log anything. But if we go to logs of this, we will see that that actual results were done. So we actually see predictions, and these predictions we got remotely via this model registered via MLflow. Well, that is a pretty good option, I would say. And same I want to show you in our remote MLflow tracking server. So if you go back to our MLflow remote tracking server, I think it's still running for the one that we just executed, but let's see some previous successful results that I ran today before their conference. So here it is, there's an MLflow run train. So here we trained a model. We have the same parameters as in Databricks. We have the same metrics. And we also have our model here. We can also easily register a model here and have model versioning. And if we go back to our runs, we can see also a scoring part. And as you can see, this is about entry point scoring using one of the model versions that was registered before. And we can't see any metrics and parameters here because scoring is just about creating predictions and writing them somewhere. That's why I can just show you where we actually store our predictions. So we have mock case container in Azure, and we have a results folder where results should be stored. And as you can see, yeah, I made it a bit before the conference, as I mentioned, like a few hours ago, but that will be updated if we again run this score run. There's a lot of information I don't understand, but I really wanted to show you many capabilities. But as you can see, it's very well configured and very well used, just via a few lines of code and via a few commands in CMD. I think that's it about the presentation mode, demonstration mode, and we can go back to the presentation to wrap up. A few best practices as a summary. My real advice is to use shared tracking servers for team collaboration. It means try to minimize using local MLflow. Try to share your experiments and runs either via Databricks or remote tracking server. If you have not very high level skilled team in MLflow and you're new in it, please start with Databricks, because as you can see, MLflow is very well integrated inside Databricks and you don't need to make any steps. With remote tracking server, it's a bit more complicated. You need some engineering help to set up an MLflow tracking server. It should be running all the time. So you need either Azure Kubernetes services or some Minikube where you can run this server. But if you make this setup, you will benefit a lot for your team. Please always create experiments, log parameters, and metrics. It's very important. It can improve the speed of your team a lot. It will help very easy to compare results and find the best model. And please forget about making notes with model results and share it via your team chats. Thanks for your attention. That's it for today.